In this tutorial, we are going to solve questions under vibration and wave as well as sound wave. Okay, so I've got a number of questions with me here, and these questions I've gotten them from different past papers for semester 2. The past paper for 2018, 2019, 2020, 2022, and 2023. So I'll only solve the questions under vibration and wave and also sound wave. Then the next video I'm going to solve the questions under the electric field and forces and also the capacitance. Okay, so let's begin our discussion with the first one. So the first question is saying a 0.35 kg object attached to a spring of force constant 1300 newton per meter is free to move on a frictionless horizontal surface. If the object is released from rest at x is equal to 0.100 meters, find the force on it and its acceleration at part 1 at x is equal to 0.01, part 2 at x is equal to 0.050, part 3 at x is equal to negative 0.02 meters. Okay, now how do we find the force? We know that the restorant force is given by kx. Okay, in this case we are just finding the force. Okay, so it is okay for you not to include the negative, it's fine. So we'll say F will be equal to the K is the spring constant, which is 1300. Then the X, now for part 1, the X is 0.1. Okay, so my force will be equal to, I'll say 1300 times 0.1, that is 130. 130 newton. Now, when the force is 130 newton, what will be the acceleration? Force is equal to mass times acceleration. I want to find the acceleration. You can divide both sides by mass, both sides by mass. Acceleration is equal to the force is 130. The mass is 0.350. So our acceleration for the first part will be 130 divided by 0.350. That is 371.43 meters per second squared. Now, you know, sometimes since we are talking about when the spring was being stretched and released, you can also assume that this is the maximum acceleration. So you can also use that formula for maximum acceleration and you end up finding the same answer. What do I mean? The formula for maximum acceleration starts from here. We know that the restorant force is equal to kx. So where there is force, I can replace it with the ma. So ma is equal to kx. Divide both sides by m, both sides by m. A will be equal to kx divided by m. So if I plug in the values here, I should get the same answer. Okay, the x is 0.1, then the m is 0.1, sorry, 0.350. So the acceleration here will be 371.43 meters per second squared. So we end up having the same. So even if I use this formula or the other one, force is equal to mass times acceleration, I will end up getting the same answer. Okay, so that is it for the first part. Now the second part, you can pause the video, find the force and acceleration, and let's see if you're going to get it correct. So now there we go. We say the force will be given by kx. The k is 1300, the x is now 0.050. So we end up having 1300 times 0.05, that is 65 newtons. What is acceleration? So the acceleration will be given by the force divided by the mass. So the force is 65, the mass is 0.350. So acceleration will be 65 divided by 0.350. So I'm getting 185.71 meters per second squared. That is the answer. Let's go to part 3. So part 3, we'll use the same formula. Force is equal to kx. Now the k is 1300. The x is negative 0.02. So what will be the force? So it will be 1300 times 0.02. So this is going to give me 26, negative 26 newtons. Because this is negative, so it's going to be negative. Now, what does it mean? This negative is just showing us to say the object was now going in opposite direction. Okay? So now, how can we find the acceleration? Acceleration is equal to the force divided by the mass. So the force is negative 26. The mass is 0.350. Acceleration is going to be equal to 26. We divide it by 0.35. Okay, so we end up having negative 74.29 meters per second squared. As simple as that. Now, if we go to part C, part C is saying a stone is dropped from rest into a well. The sound of the splash is heard exactly 2 seconds later. Now the question is, find the depth of the well if the air temperature is 10 degrees Celsius. This question I solved it. Okay, I solved it. So I'm going just to put the video in the next one. Then same applies to part D. I solved it.